Bridges over the sea, how do they even exist? Imagine constructing something massive over deep water, dealing with strong waves, unstable seabeds, and unpredictable weather. How do engineers make sure they don't collapse? Today, we're diving deep into the secrets of sea bridge construction, the engineering marvels behind them, and some of the most incredible bridges in the world. Stay till the end because I'll reveal the longest sea bridge ever built. Its length will shock you. Let's get started. 1. Understanding the challenges of building over water. Building a bridge on land is one thing, but doing it over water, especially the sea, is an entirely different challenge. Engineers must consider deep and unstable seabeds. Unlike solid ground, the seabed can be soft, rocky, or uneven, making it difficult to build stable foundations. Strong water currents and waves. Constant movement of water can weaken structures if not designed properly. Extreme weather conditions, storms, hurricanes, and even tsunamis can put a bridge at risk. Heavy traffic loads. These bridges need to support thousands of vehicles every day without wearing down. So, how do engineers overcome these challenges? Let's break it down. 2. The three main methods of building sea bridges. There are three main techniques used for building bridges over the sea, depending on the depth and structure needed. Method 1. The piling technique for shallow waters. Engineers drive massive steel or concrete pillars, piles, deep into the seabed. These piles act as the foundation, transferring the weight of the bridge down into solid ground. Some piles go over 100 meters deep to ensure stability. Example: the Golden Gate Bridge uses a strong piling system for support. Method 2. The caisson technique for medium depths. Engineers sink huge hollow concrete or steel structures called caissons into the seabed. Water is pumped out from inside the caisson, creating a dry underwater workspace where workers can build foundations. This technique is perfect for deeper waters where piling isn't enough. Example: the Öresund Bridge, Denmark, Sweden, was built using this method. Method 3. The suspension and floating bridge. Technique for deep waters. Suspension bridges use massive cables connected to tall towers, distributing weight evenly without needing too many supports in the water. Floating bridges are built on hollow airtight pontoons that sit on the water and are anchored in place. Example: the Akashi Kaikyo Bridge in Japan is one of the longest suspension bridges in the world. Now that we know how these bridges are built, let's look at the construction process step by step. 3. Step-by-step process of building a bridge over the sea. Here's how engineers construct these massive structures from start to finish. Step 1. Surveying and planning. Engineers study the seabed using sonar and drilling tests to check the depth and strength of the ocean floor. A detailed blueprint is made to decide which construction method to use. Step 2. Foundation construction. If the bridge is in shallow waters, piles are hammered into the seabed. For deeper waters, caissons are lowered and sealed to create a stable foundation. Step 3. Building the support towers or piers. Concrete or steel piers, support columns, are built on top of the foundation to hold up the bridge deck. This process can take months or even years depending on the depth of the water. Step 4. Constructing the bridge deck. Massive steel or concrete sections are lifted by cranes and placed onto the support structures. Suspension bridges use huge cables to hold up the deck, while floating bridges use anchored pontoons. Step 5. Finishing touches and safety tests. Engineers install roadways, barriers, and lights, ensuring the bridge is safe for vehicles. Finally, extensive safety tests are conducted, including simulations of storms, earthquakes, and heavy traffic. And just like that, a massive bridge is ready to connect two distant places over the sea. The most incredible sea bridges in the world. Now that we understand how these bridges are built, let's take a look at some of the most impressive sea bridges ever constructed. Hong Kong-Zhuhai Macau Bridge, China, the longest sea bridge. Length, 55 kilometers, 34 miles. It connects Hong Kong, Zhuhai, and Macau over the ocean. It even has a 6.7-kilometer underwater tunnel to allow ships to pass. Chesapeake Bay Bridge Tunnel, USA, bridge and tunnel combo. Length, 28 kilometers, 17 miles. This bridge has tunnels that go underwater so ships can pass over it. Øresund Bridge, then Denmark, Sweden. A bridge that turns into a tunnel. Length, 16 kilometers, 10 miles. It starts as a bridge but then goes underwater into a tunnel. Which of these bridges amazes you the most? Let me know in the comments. 5. Future of sea bridge engineering. The future of bridge construction is getting even more advanced. Engineers are now working on self-healing concrete that can repair cracks automatically, smart bridges with sensors that detect damage before it happens, floating bridges that adjust to rising sea levels. The next time you drive over a sea bridge, just remember, you're riding on a masterpiece of human engineering. Did you enjoy learning about sea bridges? If you did, make sure to smash that like button and subscribe for more amazing content. And let me know in the comments, should I make a video on underwater tunnels next? Thanks for watching, and I'll see you in the next video.